afternoon, everyone. Am I audible? Am I audible, students? Can you hear me? Please mention in the chat box whether you can hear me or not. Okay. So I am audible. Okay. So how was your holiday? It's holiday only, but then also it is a vacations. I hope you are studying. Okay then. So let us start. Okay. Let me share my screen. Okay, so before starting, today I have shared with you one PDF regarding the third module. Okay, so I have shared in the CR group. So CR of section A, you please share it with your classmates. Okay, I have given the notes for your module 3. Okay, first I thought that I will be giving you the assignment, but I think it will be better if I can give you the notes. So I have provided you the PDF of your air pollution and soil pollution, noise pollution. So you go through that module. That module, I don't think is it's very tough. Okay, it's a very simple one, all about the pollution thing. So you go through that, okay, by your own. And I have given all the important this one notes, okay, like what are the causes of pollution, causes, then preventive measures, all those things I have provided, okay. So you go through that, and also you can, if you want, you can write by your own also from Google. You can search and you can make your own notes also, okay. So that is from Google itself. I have got it from Google only, okay. So if you want, you can write it by your own also. So that module 3, you can take it, you go through, and you can think that your module 3 is finished, okay. So all about pollution. And okay, last class, I think we were doing about BOD expression. First stage BOD expression, I think we have completed, right? As far I remember. As far I remember, I have completed your first stage BOD equation, right? Am I right? Or we were in the middle of the equation? Did we complete the ultimate expression? Up to here, did we complete? Yes, I also remember. Yes, okay, to say yes, okay. Okay, then I think that this expression or this equation is clear to you. I hope that you have gone through at your home this derivation. It's not that tough, okay. So if you have not yet gone through this derivation, and it is necessary for you to go through, okay, because otherwise it will be not clear to you, and memorizing will not do, okay, because this is a derivation, and you should understand each and every step of this derivation, okay. So don't memorize, just go through step by step. If you don't understand, then you can ask me, okay. uh, Okay then, so after this derivation, we have done the numericals also. Okay, so this part is finished. Next is, uh, so next is about population equivalent. Okay, one term is there, population equivalent, related to beauty itself, and the other one is your relative stability. Okay, so population equivalent, you see, in short, okay, in simple sentence, if I tell you that this the industries, or there's you can say the big industries, actually they have to, give charge to the municipalities for the for the pollution they are creating. Okay, or you can say for the treatment they need to do. Okay, so they need to give a charge to the municipalities. So actually population equivalent, it gives you the strength of the industrial wastewaters. Okay, it gives you the strength of the industrial wastewaters, and it gives you the estimate of the treatment, or how much treatment will be required at the municipal sewage treatment plant. Okay, and also it gives you or it helps in gives you realistic charges, like it tells you how much charges you need to give for the treatment. Okay, they have to give some charges to the municipalities. So that is in short, it is about population equivalent. Okay, and these charges, they are in terms of BOD. Okay, they are in terms of BOD, but not by volume. Okay, like how much volume of sewage they are discharging. The charge is not up to that. Okay, it is on BOD. Okay, so this is all about your population equivalent, and there is one expression, or you can say formula for your BOD. Sorry, population equivalent. So this is your this part you see, this one. This one is your definition for your. Oh no, sorry, not this one. This one. Okay, this one is your population equivalent formula. Okay, sorry, not this one. Okay, wait, wait. Not this one. This one only. This one is your population equivalent formula, which gives you, like, it tells about the BOD of the industry in kg per day divided by 0.08 kg per day per person. Okay, so what is this 0.08 kg per day per person? It is the average standard BOD. Okay, it is the average standard BOD of domestic sewage. Okay, and the average standard BOD of domestic sewage, it is found to be 0.08 kg per day per person. Okay, and the BOD, you can say BOD of sewage coming from industries, it is also worked out already, and it is something like 300 kg per day. Okay, so this is all about your this formula. It will be used for your, like, doing the numericals. Okay, so this is all about your population equivalent, and the next terminology is your relative stability. So what is relative stability? Okay, so it is, the this term, it is defined as the what ratio of oxygen available in the effluent. Okay, it is the ratio of oxygen available in the effluent to the total oxygen required to satisfy its first stage BOD demand. Okay, so it is expressed as a percentage. Clear? So it gives you, like, the DO content. Okay, it is the DO content present in nitrates or nitrites, so all these things. So it is the ratio of the oxygen that is available in the effluent to the what, to the total oxygen that is required to satisfy the first stage BOD expression, or the first stage BOD demand. Okay, so these two are the formula for your relative stability. One is for your 20 degrees Celsius, and the other one is for your 37 degrees Celsius. So the relative stability, it is found in two types of temperatures. One is your 20 degrees Celsius, and the other one is your 37 degrees Celsius. Okay, so in the let's see some numericals related to this population equivalent and relative stability. So you see this numerical. This is a numerical related to population equivalent. The question says, as the average sewage flow from a city is 80 into 10 to the power 6 liters per day. If the average 5-day BOD is 285 milligram per liter, compute the total daily 5-day oxygen demand in kg and the population equivalent of sewage. Assume the per capita BOD of sewage per day is your 75 gram. So we need to find out the population equivalent. Okay, so we have the formula like BOD. It's divided by what? By the per capita BOD of sewage. Okay, so you see the quantity of sewage that is flowing per day. Okay, the average sewage, or you can say the quantity of sewage that is flowing per day, it is your 80 into 10 to the power 6 liters. Okay, so it is given in the question. This part is given in the question. It is the sewage flowing per day. So what is the average 5-day BOD? It is also given as your in the question as your 285. So 285 milligram per liter is also given. So now average 5-day BOD is given. So we can now easily find out the total daily total five means daily 5-day oxygen demand. Okay. So 5-day average 5-day BOD is given. So what we need to do? We just need to multiply this both. Okay, if we multiply this both, then we will get the total daily 5-day oxygen demand. Okay, so the 5-day oxygen demand by multiplying, we get it to be in kg they have converted, so it is your 22,800 kg. So why in kg they have converted? Because obviously we know that in the population equivalent formula we need the BOD in your kg. Okay, in the formula it is in kg, so we have converted it to kg. Okay, so now the population, using the population equivalent formula, it is a BOD. Okay, 5-day oxygen demand divided by your per capita BOD of sewage. Okay, then we got it to be this answer. Okay, just putting in the formula of your population equivalent. Okay, so next is your relative stability. This numerical. Okay, this is a relative stability numerical, and this numerical, the question is, you see, read the question. If the period of incubation is 10 days at 20 degrees Celsius in the relative conductivity test of sewage, calculate the percentage of relative stability. Okay, so here it is given that 20 degrees Celsius is given. So just now we have studied that one relative stability this experiment, it is done on one is done on 20 degrees Celsius and the other is done at your 37 degrees Celsius. So we have to know that like in the question itself, the temperatures will be given. So if it is given like 37 degree, so you have to use the 37-degree formula. And since here it is your 20 degrees Celsius given, so we need to use the 20 degrees Celsius formula. Okay, simple. So here the formula, this is the formula. Okay, already we have got before. So this is the formula. So now just put it. Everything is given. Every formula is given. Just you need the this T20 is how much it is given? 10 days. Okay. So 10 days is given. So you just in place of T20 you will be putting 10. If it is in place of in the question it is given for 20 degree, it is 20 days. So you will be writing here 20. So simple. Very simple formula. Okay. Simple formula and simple numerical. Okay. Two marks it will be carrying, or sometimes it carries 1 mark also. Okay. So very simple. There is nothing that you can't understand. Okay, so it's very simple. Okay, so next. Okay, next. Coming out of your BOD and COD, that chapter. Okay, coming out of that chapter now. So next is about your sewers. Okay, next is about your sewers. So from since we are starting this chapter of sewage, okay, this module of sewage, you have been hearing the word sewer. Okay, so for in the first class itself I have told you that the sewer is what? It is a pipe, okay, from where the sewage it flows. Okay, so that is a sewer. So now in this chapter or in this the same unit, you can say here, we will study about the shapes. Okay, so why a sewerage system it is important, and for how a sewer pipes are laid. So all these things we will study. Okay, so first of all, your what are the shapes of sewer pipes? So sewer pipes, obviously, by if somebody asks you what are the shapes of sewer pipes, you will obviously say that it is circular. Okay, by seeing itself, no, like it comes to our mind that the sewer pipes it is circular. Okay, but it's not so. Okay, but there are, there are shapes. There are different shapes for your sewer pipes. Okay, these are generally circular pipes, but then also, other than circular also, there are your different shapes of your sewer. So you see what are the shapes of sewer other than your circular pipes. Okay, sorry, circular sewers. So number one is a standard egg-shaped sewer. So I will show you the directly the diagram. Okay, so this is a standard egg-shaped sewer. This is your modified egg-shaped sewer. Okay, so different types: horseshoe sewer section, parabolic section. Okay, this is semi-elliptical section. This is rectangular sewer. Then this is your U-shaped section. This is semicircular section. Okay, you here you just need to know the diagrams. Okay, the diagrams are important. You can along with the names, you should be able to remember the diagram also. So if somebody asks you what is a U-shaped section or what is a basket handle section of a sewer, so you should be able to tell. Okay, so these are the shapes of seaweed. Okay, so now next is your the factors considered for selecting material of seaweed. So what are the factors that are considered for selecting the material of a seaweed? So that is a little bit important. So first of all, it should be, first factor is what? Resistance to corrosion. Okay, so the sewage, you can say the sewage, it carries what, or it releases what type of gases? The hydrogen sulfide gas. Okay, so this gas, when it comes in contact with moisture, it can be, converted to sulfuric acid. Okay, so this formation of this sulfuric acid, it can lead to the corrosion of what? Sewer pipes. Okay, so the sewer pipes, it should be selected. It should be selected in such a way that it should be, resistant to corrosion. Okay, and it should be having a long life. Okay, so next is your resistance to abrasion. Okay, so the sewage, it consists of certain amounts of suspended solids. Okay, then these suspended solids, it has some, half part is your inorganic solids, which contains, like sands or grits or debris, all those things it consists. Okay, so these particles, when they move, at a higher velocity, when the pipes or the sewage, it moves at a high velocity. So what happens? It can cause wear and tear of the sewage pipe. Okay, internally. So internally, it can cause the wear and tear of the sewage pipe. So this abrasion, this is called abrasion. Okay, so this abrasion, it can, reduce the thickness of the pipe. Okay, so when it cause wear and tear, so abrasion happens, and so this can reduce the thickness of the pipe, and also it can reduce the hydraulic efficiency of the sewer. Okay, by what? By making the interior of the sewage pipe very rough. Okay, so next is your strength and durability. So this the sewer pipes, okay, the pipes, it should have a very sufficient strength to withstand the all the forces that it can come contact. Okay, that it is likely to come in contact. So these sewers, they are subjected to, like external loads are also there, traffic loads are also there. No, these are put underground, so above the cars will go, the trucks will go, so it should be able to, it is subjected to external loads also. Okay, so they are they should be, they should be withstand. They should be able to withstand this external load safely without failure. Okay, and in addition to that, you can say that the material, it should be selected in such a way that it should be durable, and it should have some sufficient resistance against what natural weathering action. Okay, it should have sufficient resistance against your natural weathering action. So next is your weight of the pipe. So the material, it should be of the sewer pipe. It should be selected in such a way that it have a less specific weight. Okay, so it should have a less specific weight, and so that the lightweight pipes, because when the pipes, it will become heavy, so it will be very difficult for the construction people to handle and to transport those pipes. Okay, so if it is light in weight, so it will be easy for your handling and transport purposes. Okay, so next is your imperviousness. Okay, so imperviousness is like to eliminate the chances of sewage seepage. Okay, from sewer to surrounding. Okay, so like some, you have seen some pipes, like the waters are coming out, that they are seeping through the surface of the pipe. So it should not be like that. Okay, it should be impervious in nature. And also next is the economy and cost. Like the sewer pipes, it should be less costly. Okay, and it should be economical also. And the sewer pipes, it should have a smooth interior surface. Okay, and so that it has less friction. Okay, so that it has less friction, so the interior surface, it should be smooth. Okay, so these are the factors affecting your selecting the material for your sewer. Okay, this one I will share by today. Okay, this PDF I will share it. So next is your okay, next is your like requirements of design and planning of sewerage system. So why like the sewerage scheme, it is important for for planning and designing. So everybody knows that the sewerage scheme or the system, it is designed to remove the sewage, the whole sewage effectively and efficiently, from the houses, from the customers' houses, to the point of disposal, or to the point of treatment and then disposal, you can say. Okay, but again, there are following aspects which should be considered while you design the sewerage scheme. Okay, or sewerage system. Okay, so like first one is like the sewers, it should be it should be provided, it should have some adequate size. Okay, in order to avoid overflow and possible health hazards. Okay, then for evaluating or estimating the proper diameter of the sewer, correct estimation of sewage discharge is necessary. Okay, how much of sewage will be discharged, so you have to properly, you have to accurately estimate, then only you can after that only you should choose the diameter. Okay, how what diameter of sewer you should uh, choose. Okay, so for that you need to know the correct amount of the discharge, how much of sewage is discharged. So next is your like the flow velocity inside the sewer, it should be neither large or it should be neither low. Okay, then next is your like the sewers, it should be laid at least 2 to 3 meter deep. Okay, to carry sewage from basement, it should be the sewers, it should be carried 2 to 3 meter below the ground level. Okay, the sewage, it should be flow under gravity. Okay, like with 0.5 to 0.8 full at design discharge, that is the maximum estimated discharge. So it should flow under your gravity. So next is your the sewage, it is conveyed to the point usually located in low-lying area where a treatment plant is located. So this one is similar like your raw water, like we have studied, no, like this low-lying area, the treatment plant is at a low-lying area and the sewage is coming from a high area. So it is flowing through gravity and to the treatment plant. Okay, So, and also the treatment plant, it should be designed taking into consideration the quality of raw sewage expected to meet the discharge standard. So, the treatment plant also, it should be, they should design uh, they should consider what kind of, what quality of raw sewage it is coming to the treatment plant. Okay, so these are your, some of the factors you can say, or some of the aspects you can say that you should um, consider while you design a sewerage system. Okay, so next is your, okay, so next is your laying of the sewer pipe. So how the sewer pipes are laid. Okay, so these are the steps. Okay, these one, two, three, four. Some steps are written here. Okay, so these steps, I want you to read these steps first of all by your own. Okay, these are some of the, ways how a sewer pipes is laid. So these steps I want you to read by yourself first. Okay, then if you don't understand, then I will explain you. Okay, and the second thing is that the after this PDF, one more PDF is there. I will show you it. This one. I hope you can see some. It's dark, little bit dark. Okay. So this one is about your sewer appurtenances. Okay, what is a sewer appurtenances? Okay, those are structures which are constructed at suitable intervals along a sewerage system. Okay, so actually the thing is that before already I said that, first of all, previously, it was fifth sem and sixth sem, and sixth sem is already all about your sewage system. Okay, so we were going in details. Okay, that time we were going everything in details because there was time. Okay, but now the thing is that if I start explaining you each and every details, so I hardly had, in ERP system, I think I have 15 classes or 12 classes like that left. Okay, it is up to November 20 or something. So there is no time left so that I can, explain each and every things to you. So okay, some kind of support I need from you also. So I am not giving you the hard things to go through. Okay. So these are very, very simple things, that these are, like simple English written in the book. Okay. This book is very good. So I have already, those who have not, brought this book. So I have already given you the PDFs here. Okay. So that it will be easy for you. Just the thing is that for this your appurtenances, you need to go through by yourself. Okay, is it clear to you? Because this is very simple. Like, see, these are no sewer appurtenances are what? These are structures that are constructed at suitable intervals along a sewerage system. Okay, and all these things you have already seen. Like, not all, but these sewer appurtenances. Okay, like manholes. Manholes everyone have seen, yes? So manholes you have seen. Drop manholes also you have seen. Okay, if you studied and you will know what is a drop manhole. Okay, so this 10 manholes, drop manholes, lamp holes, clean outs, these all these things, it's very clearly, very nicely, it is presented in this book. Okay, everything is written very clearly, very nicely. So I want you to go through this first of all by yourself. Okay, because next class I want to start the treatment part. Okay, treatment part is very vast actually. So I want to start the treatment part on Friday class. Okay, so now also less time is left, not much time. So what I'm telling you this is that I will be sharing this PDF with you today itself. Okay, these are small things you can see. Okay, there are small things like catch basins. All these details are written. Okay, what are all these things? So you just go through. Okay, go through all these things and do one thing. You select some important lines from all these things. Like you select some 3 4 lines from here. whatever is important, you write down in your copy. I think that will be a good thing, because if you see it in your mobile, or if you see it in a laptop, so I don't think that will be you will be able to remember something. Okay, so if you write it in your own handwriting in your copy, so I think it will be more easy for you to remember something. Okay, so you try to uh, pick it out some important lines from here, all these things, and you write it down in your copy. Okay, these things, and also your this one. Just now I have this laying of sewer pipes. Okay, this laying of sewer pipes, and your this testing also you can go through what tests are done on our sewers. Okay, this two and the sewer appurtenances, so you go through by yourself, and if you by any chance if you don't understand, then in the next class you come and tell me that, ma'am, I have not understood this part, please explain. Okay, then I will explain it to you. But first of all, I suggest you to go through it by yourself. Clear to you, everyone? So after this class only, I will be sharing with you these two PDFs. Okay. So 5 minutes are left. So let me quickly take the attendance. Okay. Okay. Roll number one. Roll number
Yes,
one.
ma'am.
Okay. Roll number
Yes,
two.
ma'am.
Roll number two. Three.
Present, ma'am.
Four.
Present, ma'am.
Five. Six. Seven. Roll number seven.
Yes,
Eight.
ma'am. Present.
Okay. Eight. Eight. Nine.
Present, ma'am.
Nine. Okay. 10. 11. 11. 12.
Present, ma'am.
12. Okay. 13.
Yes, ma'am.
Yes, ma'am.
Okay.
13.
14. 15. 16. 17. 17. 18.
Yes, ma'am.
Okay. 19.
Yes, ma'am.
20. 21.
Ma'am.
22.
Yes, ma'am.
23.
Ma'am, 19 is present.
19. Yeah, 19 I have
Yes,
given
ma'am.
present. Given present. Okay, so 23. 23. 24. 25.
Present, ma'am.
26.
Yes, ma'am.
27. 28. 29. 28
Yes,
present.
ma'am.
28 is present. 29.
Yes, ma'am.
Okay. And 30.
Present, ma'am.
Okay. 31. 32. 32. 33. 34. 35. 34 present. Okay. 35. 36.
4 present, ma'am.
Yeah, yeah. 37.
34 present.
38. 39. 40.
Yes, ma'am.
Okay. 41.
Present, ma'am.
Okay. 42. 43.
Present, ma'am.
Okay. 44. 45. Okay. Who is present? Next. 44 is present. Okay. Okay. 45, 44 present. 46,
Present, ma'am.
47, okay, 46, 47, 48, 49, 50. Okay,
Ma'am,
now
roll number 2 present.
rule number 2 present. Then anyone
Yes,
else
ma'am.
left out?
Ma'am.
Yes?
11.
11.